Something truly fundamental is shifting in the world of artificial intelligence. We're witnessing a move away from AI that just predicts things to an AI that can actually solve problems. So let's get right into what that means.
I mean, we've all seen it, right? AI can write beautiful poetry, it can spit out complex code in seconds. It's incredible. But that begs a really important question. Is it just a super advanced mimic, just repeating patterns it's learned? Or can it genuinely think its way through a problem it has never seen before?
And this, right here, is the absolute heart of the matter. For years, AI has been a prediction machine. Its entire job was basically to guess the next word in a sentence. But reasoning? That is a whole different ballgame. It's not about guessing. It's about a careful, step-by-step process to actually figure something out.
Okay, so to really understand why this shift is such a massive deal, we first have to talk about the old way of doing things. We need to look at the built-in limits of just predicting the next word, or what the experts call next token prediction. So even the smartest models out there today are at their core just a very, very fancy version of autocomplete. They are absolute masters of spotting patterns in the mountains of data they were trained on. But, and this is a big but, it means they don't have any real grounded understanding of what they're talking about. But this is where things get really, really interesting. Researchers have hit on a major breakthrough. They found a new way to make AI smarter that isn't just about feeding it more data. It's about giving AI more time to think. So how does that even work? Well, instead of just blurting out an answer, these new models are being taught a process that looks a lot like how we think. They create what's called a chain of thought. They take a problem, break it into smaller pieces, explore one way to solve it, and this is the really crucial part. If they hit a wall, they can actually stop, backtrack, and try a completely different path. Now, the technical term for this is Inference-Time Compute. But don't let the jargon scare you. All it really means is the amount of mental energy or processing power an AI dedicates to chewing on one specific problem. It's the difference between a quick gut reaction and actually sitting down to deliberate. And this quote from an OpenAI researcher just perfectly captures that aha moment. He talks about seeing the model literally stop itself and say, wait, this is wrong. Let me take a step back. Seeing an AI, which was only built to guess the next word, suddenly recognize its own mistake and correct course, well, that was the moment they knew something profound had changed. And this is so, so important. We've unlocked a totally new way to make AI smarter. For the longest time, the only strategy was just more data and bigger, more powerful models. That was the game. Now we know we can get huge performance boosts simply by letting the model think longer. The ceiling on how capable AI can be, it just got a whole lot higher. Okay, so this is all really cool in a research lab, but what does it mean out here in the real world? Well, it turns out we're already seeing these new reasoning skills deliver expert-level results in some incredibly important fields. Just take a look at this. This data is from the UK's AI Safety Institute, and it's showing how well the latest AI models are doing on really hard biology problems. The trend is just undeniable. In a little over a year, the performance is on track to double, going from basically failing the test to coming up with solutions that have all the right pieces. And what does that look like in practice? Well, an AI can now write up a complex, super detailed protocol for a lab experiment in a matter of seconds. For a human scientist, even an expert, that same task takes hours. This is a massive accelerator for science. Just think about that. And we're seeing the same kind of exponential growth in cybersecurity. The complexity of tasks an AI can handle all by itself is doubling about every 8 months. We're going from simple 10-minute jobs to complex, hour-long operations that until now needed a seasoned human expert. The pace is just staggering. But this isn't just happening in technical fields. As these models get better at reasoning, something fascinating is happening in society. That same AI Safety Institute found that a third of people in the UK have already used AI for emotional support. A third. This is no longer just a tool for work, it's becoming a part of our personal lives in some deeply human ways. Okay, so this reasoning thing is clearly a giant leap forward. But let's zoom out. Where does this fit in the bigger picture? The quest for artificial general intelligence, or AGI. Because true, human-level intelligence isn't just one thing. It's not just logic. It's more like a complex symphony of different abilities all working together. And the best blueprint we have for that, of course, is the human brain. And this table here lays out the roadmap pretty clearly. Reasoning, that's just the first piece of the puzzle. To really get to AGI, You also need things like persistent memory, like our hippocampus. You need the ability to actually act in the world, like our motor cortex. And you need to build internal models of how the world works. Each one of those is its own massive challenge for AI researchers to solve.
And naturally, as we go down this road, we slam into some huge challenges that are not just technical. We have to start asking some really tough questions. How do we make sure these things are fair? How do we stop them from being misused? What's the impact on jobs and society? Not to mention the absolutely massive amount of power these things consume. There's a lot to figure out. Which brings us to our final question. And it's really the big one. This new era of AI is here. We're building machines that can problem solve in ways we're just beginning to wrap our heads around. The technology is learning and adapting at a breathtaking pace. So the real challenge now is for us. Can we learn just as quickly how to guide it all to a future that's safe, fair, and better for everyone?